Okay, we are on step 4. So the first thing we want to do is go ahead and get our setup for our probability for each one of the potential um, levels of male accidents. So I'm going to do this, and then as we do it, I think you'll understand what's happening. We're going to start with an if statement. And we want to know that our sample number is going to be greater than or equal to the actual number of trials. Hit F4 to lock that in. And that way, because our next step is to do a binomial. So we want another binomial distribution. And in this case, the number of trials is actually our event. And then, or the number of successes. The number of trials is our trial value, and we'll hit F4 to lock that in. Our probability is going back to our descriptive statistics. So we want our percentage of male, and we'll hit F4 to lock that in. And then we want non-cumulative, so an exact value. And I just forgot a parenthesis there. We actually need another parenthesis here, and well, it's not working right. If C9 is less than or equal to B4. So we want that in there because if we have potential number of successes that greater than the number of trials, then the binomial distribution is just going to throw an error. So this is just a simple error trap. Next thing is, what's the expected value? In other words, what's the expected cost per accident if there are zero males? So again, we're going to do an if statement, and we want to make sure that we're in a, sorry, we got to put an equal sign. Equal if, and we want to make sure, again, that we're going to control for any kind of, we're in an error trap, basically. So all this is saying, as I mentioned before, is that the number of successes has got to be less than or equal to the number of trials. And then in this case, right, so we have 0 males, which means we have 10 females. So what's the expected value of the cost per? So it's going to be the number of males multiplied by the conditional cost for male. It's the conditional mean sheet. So we'll pick that one, hit F4 to lock it in. And then we add to that a parenthesis. Come back here, and it's going to be the number of trials, F4 to lock that in, minus the number of males, right? Because if you're not male, you're female. We multiply that by our conditional cost for females, and F4 to lock that in, and the parenthesis, and then we want the average, so now we're going to divide by the total number of trials, and we'll hit F4 to lock that in. Then a comma, and then should be 2 parentheses. Nope, just 1. So, and then just as an intelligence check, right? So this is turn it to accounting value. This is 3,216.50, which should be our conditional mean because all we have is females. So that's working out correctly. Now the contribution is going to be the probability multiplied by the expected value in that position. So I'm going to go ahead and drag this guy down. Or I'm just going to go down to 10 because I got 10 trials, right? So this is the probability of event times the expected value in the event. This is the contribution to the overall mean. And what I mean by that, we're going to do another check here. If we run a sum of all of our contributions, we end up with 3,289.46. If we look at our descriptive statistics, our mean on claim costs 3,289. $289.45, so that rounds up to 46 cents. So your interpretation here is these are all the potential conditions that can happen. If we multiply that by the expected value in each one of the conditions, then we actually end up with the total expected value. All right, and then we'll actually want to go ahead and this is how the air trap works. As we drag down, I'm just going to drag down to the end. You'll see that we end up with just zeros and dashes because there's nothing to calculate. Okay. With nothing to calculate, then it's just going to enter the if statement. So this says if this is true, do the binomial distribution, else don't do anything, which is going to put a 0 on. Okay, now let's do the at most, for example. At most, we want 5 positions. In other words, this should be equals the sum, and then we would just want 1, 2, 3, 4, 5, up to 5, at most 5. Okay, and then this becomes the expected contribution. When you say at most 5, you're restricting the event space. So I'm going to come to my simple little section here. When I say at most 5, so that puts me in this area. What I'm also saying is that these are not part of the event space. So the probability question is, what is the likelihood given 11 events that at most there are 5 males? And that gives us our answer 0.61. Okay. Now the expected value, in other words, how much is it going to cost per accident in this condition, is the sum of each one of these guys. And you'll notice that the probability is not equal to 1. But the event question says we're going to restrict it to at most 5. So we got to make this thing actually equal to 100% probability. Again, what the question is asking, what's the probability that at most 5 males are in an accident? The answer is 61%. If only 5 males are involved, up to 5 males are involved in an accident, that's restrictive, meaning we have to make it 100%. This is called a conditional expectation. So now we need to divide it by our at most value. And so our expected value, if we have 5 males, at least 5 males, right? Or I'm sorry, at most 5 males. So no more than 5. So 0 is fine, 1 is fine. You can see 0 is less than, but it's also a lower probability. We'll end up with an expected value here of 3,274. Now what we want to do, though, is make this so it's automatic. I don't want to have to come back in here and edit the sum every time I change my underlying probabilities. So I'm going to change our equation here, equals sum, and then we're always going to start, because this is an at most, so it's 0 through whatever. We're always going to start here at F9. That's not a problem. And then we're going to use a function. Nope, colon, get rid of the new F9. It's called indirect, and that's going to allow us to do relative referencing. And then we're going to use concatenate. All right, and what we want to concatenate, we're in column F, so we want quote F quote, and then we're going to concatenate to that our B1, which is the at most number, and then we're going to add to that 9, and then we need 1, 2, 3 parentheses, and now we're going to divide by our probability to get the restrictive question answered. So we'll just hit return and we'll come up with the exact same number. Now if I change my at most to 6, it's going to change the sum. So instead of going from 0 from this number to 5, it's going to go to 6, and the number is going to come up. And then if we do 10, okay, at most we have 10 guys, which means we might have 0, we might have more. We should end up with just the overall average, because now we're summing up over the entire event space. So we're summing between no men and up to 10 men. So that's just a sum over the entire event space, and therefore we end up with our 380 or 3,289.46, just the total. All right. What was that? Just go back to 5 to start with. You notice the probabilities update as well. So let's get our next conditional if. This one's a little bit different. So in this case, if we're doing at least 4, then what we want for just that one will be the sum. And then we're going to start at 4 and come on up to the end. And then we would go ahead and divide by our at least probability to make it all one. That number is not right, I don't believe. Let me pause here real quick. I might have a small error in my code. All right, I did have a small error. We need to come back to this one. It should be B2 minus 1. Because it's at least 4, so we need to get from 0 to 3 out of there. And now we have a much more reasonable value associated with it. And just as a quick check, if we go to 0, at least 0, at least 1, that actually does 0. And, well, we got to change the sum as well. In fact, that actually is one of the problems here. We should probably put an if statement in front of this. I'm not going to, because at least 0 doesn't make much of a sense. But anyway, we can put an if statement in here that says if at least is equal to 0, then our probability distribution is from 0. We just would enter 0 up instead of the minus 1. All right. And then this one is wrong because of the summation issue. So what I want to do is, again, we're going to sum, and now we're going to start with an indirect and our concatenate. And then we want to start again at F, and then we're going to do our B2, and we'll go ahead and F4 that. And then we're going to add to that 9. And that's the end of our concatenation. And then we're going to use another indirect and a concatenate. Also in the F column. And then we're going to have our B4, which is the number of trials. Hit F4 to lock it in. And then we're going to add 9 to that. And then we're going to divide by our underlying probability. All right, and the 9 is coming in because from the trials, we're just going down to 9. So if I'm at 1, I need to add 9 to it to get down here, which is where the 9 comes from. It's just shifting from this value, moving it down to the beginning of this, or moving it down even farther. Okay? So that's the 9. Now the exactly is really straightforward. It's just going to be equals indirect, and then our concatenate. And now we want E, and then what we're going to look for is our B3, which is our exactly, and I can F4 lock that in, and then plus 9. And we're done. So as you can imagine, let's see, $. If it's exactly 5, I just come down here to 5 and read the expected value. Because again, we're restricting the event space. We're saying none of the other events happen. We only have this event that occurs. There's exactly 5 males, which means there's also exactly 5 females, because there's 10 trials. And therefore, this is the expected cost per accident at that point. All right. 15 minutes into it. That always takes longer than I think. I'm going to go ahead and pause the video here, and then we'll go ahead and do the female side. Thank you very much, and we'll go from there.